my today's sessions on network analysis. Today I am going to discuss about the analysis of AC circuits. Myself Dr. Sayanti Chatterjee, Associate Professor of Electrical and Electronics Engineering Department of EEE. So as I told that what is the objective? Already we have discussed many times. This is only for one quick discussion that today our main objective is the objective to present the necessary mathematical background for the transient of DC and AC circuits and study the transient using differential equations and Laplace transforms for the series and parallel circuits. Also, we will try to understand the three-phase systems for the star-delta connected systems. So, these are the course objective of my today's class. And if we go for the course outcome, which I already discussed yesterday, today our main course outcome is based on the CO1, and that is the discuss the steady state response and resonance of electrical circuits to AC supply. Discuss the steady state response, and for that we are going for the AC supply. We will discuss the different analysis for the AC supply for the basic circuits. And from the next class, we will start the steady state response and resonance of the electrical circuits. So first we will discuss about the AC circuit analysis. What is AC? As we discussed yesterday, that circuits are basically two types. One is alternating current. And another one is the direct. Alternating current and direct current. AC, A and C, alternating current. AC refers to the current which regularly change in a directions, or the voltage that regularly changes its polarity. Polarity means if it is the positive, so next moment it will be the negative, and again it is the negative to positive. Though AC means alternating current, but any alternating quantity we will generally refers AC. AC voltages and currents typically vary according to the sinusoidal pattern. You can see here, this is a pure AC circuit which is a sinusoidal pattern, and so its equation is A sin omega t. If it starts from 0 to 180, 180 to 360 degree, this is called the one wave cycle. This is called the one wave cycle. Means this is the time, and the time taken the time taken to complete one cycle is known as the time period. This is the, again, if we start from here 270 degree, so from 270 degree to the next 270 degree is the another cycle. So cycle means from one point to the repetition of the same point. What is the meaning of wave cycle? One wave cycle from one starting to the repetition of the cycle. So this is called the time period. The time taken to complete one wave is known as the time period. So this is the basic of the AC. Except the sinusoidal, the AC may be triangular, the AC may be cosine. So AC may be alternating current. We are alternating the polarity. The equation may be anything which has the alternating quantity, but here we are using only the pure sinusoidal. And as we can represent the alternating current, as we told, the voltage changes its polarity and magnitude at the regular interval of time is called the alternating voltage, as we discussed earlier. So as we discussed earlier, the AC is changing its polarity continuously from the one point to another point. So today first we will discuss the AC through the resistor. AC through the resistor. So what is the resistive circuit? We can think this is a voltage source, and This is the voltage source, and we are connecting a resistor. We are connecting a resistor with a voltage. And what is the equation of the voltage? The equation of the voltage is always Vm sine omega t. So while, as I discussed in the previous class, in the resistor, current is always in phase, in the same phase with the resistor. We discussed in the last class that in the case of a sinusoid, this is the meaning of it is an AC or sinusoidal input. So for an AC input, when current flows through a resistor, the current is always in the same phase. There is no phase difference between the voltage and current. So if V is equal to Vm sine omega t, what is I? I will be, always we know from the Ohm's law, I is equal to V by R, and it will come Vm sine omega t by R. We know I is equal to Vm by sine omega t by R. So what is the equation of the maximum current? The maximum current is Vm by R. What is the maximum current? Maximum current means the peak current. So we can see there is no phase change. Phase means the angle between the voltage and current. Here you can see, both has been started from the same point, and the peak also, both are getting the peak at the same point. So we can think that there is no phase difference. Here also the 180 degree minus peak. One full time wave, if we go for a full wave period, it is taking the same time. So we can tell Im is equal to Vm by R, and It, what is the current It? It is equal to Im sine omega t. So Vm by R means if it is Im, so we can write Im sine omega t. So here you can see only the changes in its magnitude, but the angle remains same. So now we will discuss about the AC through pure inductance. What will happen if the AC flows through an pure inductance? As I told yesterday, one rule that is called the Seville rule. What is the Seville rule? Seville rule tells that in capacitor, I always leading and V is always lagging. So CIV means in capacitor, I is always leading and V is always lagging. Because I is first, V is second. If we go for the VIL, second part Seville, VIL, voltage is leading and current is lagging for the inductor. We have already discussed the Seville rule before only. So what is the Seville rule? We can know that L means inductor. In inductor, voltage is leading and current is always lagging. So what is actually happening? Though pure inductor is not applicable in the practical cases, but for simplicity we are thinking that one inductor is connected with a source. And what is the source? Again we are thinking about an AC source, and AC source value is Vm sine omega t. So what will happen? Current will flow through the L. Now, when current will flow, as we discussed earlier, there is a general tendency of the inductor to oppose the rate of change of current. What is the general tendency? The general tendency of the current is to oppose the rate of change of current. So we can, if there is a rate of change of current, means if Vm is equal to L di by dt. What is Vm? Vm across the inductor, across this circuit Vm, because there is only one drop, Vm sine omega t is equal to L di by dt. So what is di? Di is equal to Vm by L sin omega t. First, we will try to understand the physical interpretation, then we will go to the mathematically. So, in the physical interpretation, if you are zooming this circuit, what we are getting here? Say this one, this blue one is the capacitive circuits, and here we told the current is always lagging. What is the meaning of current? When the voltage is zero here, when the voltage is zero here, current, this red one is current is not zero. Current is always, in a pure inductor, the current always lags the voltage by an angle 90 degree in a pure inductor. So when it is, if this is the pi, means 180 degree, so the midpoint is the 90 degree. So at the 90 degree, at the midpoint, the current will be zero. So the distance of voltage is 0 at 0 degree, but the current is 0 at the 90 degree. So we can tell that the current is lagging by 90 degree. Similarly, the voltage, the blue one, becomes pi or 0 again at the 180 degree, but the current will be at 270 degree. Similar thing for the peak also. It is getting its peak at 90 degree, but the current is getting the peak, current is the red one, current is getting the peak at 180 degree. So we can think that the voltage is lagging the current by 90 degree. Now what is power? Power is equal to, we know what is power? We know power is equal to Vi cos theta. So if we calculate the power, you can see the power is in the opposite direction. It is the, depends on the angle between the voltage and current. So we got the equation Vm. Now we will go for the mathematical derivation of the equation. So what is the equation we have got? From the previous equation we got di is equal to Vm by L, because L di dt sin omega t dt. This is the equation. How we got? We know in an inductive circuit, pure inductive. Remember one thing, we are thinking about the pure inductive circuit, there is no resistance. So Vm sin omega t is equal to L di by dt. If there is a rate of change of current, the voltage will induced in the circuit. So L di by dt. So what is di by dt? Di by dt is equal to Vm sin omega t. So di is equal to Vm by L sin omega t dt. Now what we are doing? We are integrating both sides. Because we have to calculate the current. So what is I? I is, if we integrate both sides, we are getting I Vm by L integration of sin omega t dt. What is the integration of sin omega t? Integration of sin omega t is equal to minus, what is the integration of sin omega t? Integration of sin omega t is equal to minus cos omega t by omega. So we are getting minus cos omega t by omega. So Vm by omega L minus cos omega t. So Vm by omega L cos omega t means sin omega t minus 90 degree, as this is minus. So sin omega t minus 90 degree. So from here you can see our, what is our voltage equation? Voltage equation is Vm sin omega t. Current equation is equal, this is constant and we are thinking this value is Im. So we can write Im sine omega t minus pi by 2. So you can see this is the Vm sine omega t. This is Im sine omega t minus pi by 2. So what is the value? The value is the 90 degree lagging. Current is lagging the voltage minus. So it is lagging the voltage by 90 degree. So what is the current? I is will be maximum when sine omega t minus pi by 2 is equal to 1. And what is the maximum value of Im? Im is Vm by omega L. So therefore we got this two equation, and if we draw it, if this is the Vm sine omega t, it should lag by pi by 2 of the sine omega t. And so we got Im is equal to Vm by omega L. So Vm by omega L we can write that XL, because from the Ohm's law we can write Vm by Im is equal to XL. So Vm by Im is equal to XL is equal to omega L is equal to 2IFL, which is known as the inductive reactance, Now one important thing, what will happen when the AC circuit is open and short? So yesterday we have discussed about what is open circuit, what is short circuit. So what will happen when a circuit is open? So open means when the AC is not working. Open means frequency is 0, and frequency is 0 means XL is equal to 0. And when it is short circuit, again frequency is very high. And one more thing, the question will come, what is the behavior in the DC circuit? So this is another important question of the inductance. So this is we'll discuss later also in the steady state analysis. So you have to remember, when frequency is 0 for the DC circuit or short circuit, the frequency is 0 means XL is equal to 0, and Vm by XL, Vm by 0 means it becomes infinity. So in the short circuit condition, the current will be excessively high, or in the DC, if we connect with the DC, the current will be excessively high. Now let's do one numerical problem. So a 60 Hz of 115 volt RMS is impressed on a 100 ohm resistance. Write the time equations for the voltage and the resulting current. Let 0 point of the voltage be at 0. What does it mean? If we are thinking about the voltage is pure sinusoidal, and it has started from the 0 value only. So it is given that the RMS value is 115. What is the meaning of RMS? Root mean square value. And if we remember our electric circuit syllabus, we can know the relation of the maximum value is equal to always root 2 times of the RMS value. We should know the maximum value is always root 2 times of the RMS value. So what is Vmax? Vmax is equal to root 2 into V. Root 2 into 115. So what is the value? The value is coming as 163 volt. Next, what is the value of the Imax? As we are discussing about a pure resistive circuit. So Vmax by R is equal to Imax. So Vmax is got 163 volt by the resistance is came in the, according to the problem, the resistance is the 100 ohm resistance. So we can write I max is equal to V max by R. So what is V max? V max is 163. 163 by 100 is equal to 1.63 ampere. And as we discussed earlier, the angle between them is 0. Now what is the equation of a voltage? Voltage equation should be Vm sin omega t. What is the value of Vm? Vm value we got 163 volt. Sin, what is the value of omega? Omega is equal to always 2 pi f into t. What is the value of omega? Omega value is always 2 pi f. So if we f for frequency. So here in this problem it is given the frequency is 60 hertz. The frequency is 60 hertz. So 2 into 3.14 into 60, if we put, the value is coming 377 radian per second. So what is the value of the voltage? The value of the voltage is 160 sin 377 t. What is the value of current? Same equation because there is no phase difference. So sin omega t is fixed, only change the magnitude. What is the value of I max? The I max value we got 1.63. So this is one example of one problem. Let's move to the next problem. Similar problem, but we are taking it as a pure inductive circuit. What is in the problem? A 60 hertz voltage of 230 volt effective value is impressed on an inductance of 0.265 Henry. Write the time equation for the voltage and current. So let's start from the voltage equation. First we are drawing the equation. So what is this? We are giving one AC supply and there is a pure inductive circuit. This is a pure inductive circuit and the value is 265 Henry. So first we have to calculate the reactance, the value of XL. As we discussed in the previous slide, XL is equal to omega L and omega is equal to 2 pi f into L. So 2 into 3.14 into 60 into L. L is 0.265 and the unit should be in ohm. Remember everything that for the L, we cannot use the L simply. We have to change it in its equivalent reactance. We have to change it in its equivalent reactance and the unit of reactance is always in ohm. So what is the value? First we have got the value as 2 pi f. Already we discussed the 2 pi f in the previous one. 2 into pi means 3.14 into 60 into 0.265. So this is the value and this value we got 377 into 0.265. So it is coming almost 100 ohm. So the value is coming for XL is 100 ohm. Next is given in the problem the 230 volt effective value. While for any electrical apparatus we are discussing about any value is written on its name board, it is always in RMS value. So effective value is nothing but the RMS value. So already we discussed the maximum voltage is root 2V into 233. So what is the value? It is root 233. So it will come some value. So what is the equation of the voltage? Voltage equation is 230 into root 2 sin omega means 377 t. What is the value of current? The current value is always, we have already discussed, Im is equal to Vm by XL. XL value we got 100. So this is the value of the Im. So what is the current equation? The current equation is 2.3 into root 2 sine 377t minus pi by 2. So this is the, and you can again, why this is minus pi by 2? Because as we discussed earlier, the voltage always lagged the current, always lagged the voltage by an angle 90 degree. Next we will discuss about the AC through a pure capacitance. So what will happen? So again we are thinking about a pure capacitance. Current is flowing through a pure capacitance only. Again, what is B? B is equal to Vm sin omega t. Again, if we go for the civil rule, in capacitor I is always leading and voltage is lagging. And again remember, for a pure capacitance, it is leading by 90 degree. Next, if we make it big, we can see the blue one, similar thing. The blue one is the the blue one is started from 0, and the current, what is the current? Current is always leading. Leading means when it is 0, it will start from here, so that when it is 0, it is already got its peak. When it is 0, the voltage is 0, already current got its peak. And when it is got, the voltage is at its peak, the current is at 0. So you can see the similar thing here. Current is in the current is in the leading condition. The current is leading the voltage by an angle 90 degree. So if we go for the mathematical derivation, what we will get? That according to the definition of the capacitor, unlike the inductor, capacitor opposes the rate of change of voltage. Capacitor opposes the rate of change of voltage. So the current induced in due to an capacitor is directly proportional to the dV by dt. So what is the C is equal to Vm sin omega t. D by Vm sin omega t. Vm is constant. So we are doing the derivative of sin omega t. What is the value? Omega cos omega t. So what is the meaning of cos omega? Cos omega means sin omega t plus pi by 2. Sin and cos relation. So it is sin omega t plus pi by 2. Now what is the meaning of omega c? We can write it Vm by 1 by omega c. Our general tendency is we have to write the equation in the same form of the Ohm's law. So Ohm's law means Vm by R. So same type I want to write here, Vm by 1 by omega c. So 1 by omega c is known as the xc. 1 by omega c is known as the xc, which is known as the reactance of a capacitance. This is the known as the reactance for a capacitor. So as I discussed, that xc is equal to 1 by omega c. So you can see the voltage is lagging the current by 90 degree. Now what is current? Current is Vm by Im is equal to xc. Xc is equal to 1 by omega c and equals to 1 by 2 pi fc. What is omega? Omega is nothing but the 2 pi fc. So this is known as the capacitive reactance. So, sorry, it will come. So what is Vm? Vm Im is equal to Vm by xc. So it is the AC through a pure resistance. Now we will again go for another problem. The problem is a 50 microfarad capacitor is connected across a 230 volt 50 hertz supply. Calculate the reactance offered by the capacitor, maximum current and the RMS value of the current drawn by the capacitor. So what we are doing? We are doing here, we are using one source AC supply, and what is the value? 230 volt. 230 volt. Again, the 230 volt means it is an RMS value and it is connected with the capacitor of 50 microfarad. So the value is 50 into 10 to the power minus 6 farad, and it is a pure capacitor. It is a pure capacitor. So what is the XC? XC is equal to 1 by, what is XC? XC is equal to 1 by omega C. So we can write 1 by 2 pi F into C. 1 by 2 pi means 3.14, 50, because supply is 50 hertz, and what is C? C is 50 into 10 to the power minus 6. And what is the unit? The unit will be ohm. So what is omega? Omega is 2 pi F 314. What is XC? 1 by omega C, 1 by 314 into 50 into 10 to the power minus 6. So the value is coming as 63.6 ohm. What is the maximum current? So the maximum current is, we can do two types. First, we are calculating the RMS value. What is the RMS value? RMS value means IRMS, as this is a pure capacitor, VRMS by XC. What is VRMS? VRMS value we got 230 into 230 volt, and XC value we got 63.6. So this is the value of the IRMS, and the value will come 3.62, and IM maximum current is root 2 times of the 5, that is 5.11. Other process we can do, we can calculate the I max is equal to V RMS into root 2 by XC, means 230 into root 2 by 63.6, and again the same answer will come, and that is 3.62 ampere. So what is the time equation of the voltage? 230 into root 2, because V max, to remember one thing, this 230 volt is always means the RMS value. If it is mentioned it is maximum value, then only take maximum value. Otherwise, always try to take it as an RMS value. So is equal to 230 root 2 sin 314 into T, and current equation is IT is equal to 5.11 sin 314 T plus pi by 2. Next, we are going for a mix and match circuit, which is in the practical case. In the practical case, the pure resistor or pure inductor, pure capacitor we can't find. So what we want to do? We want to use a AC through an RC circuit. So you can see here, this is an RC circuit, this is the R and this is the capacitor. In the practical case, if we want to do it in the breadboard, we will connect the resistor and capacitor in the series. So what will happen? So when current will flow through this, there will be some voltage drop across the resistor. So this is the direction of current. For phasor diagram, generally if it is a series circuit, we take current as a as an base. If it is an parallel circuit, we take the voltage as a base. Remember one thing, that as I discussed earlier yesterday's class, that last class, that voltage is always in a series circuit, current is fixed throughout the circuit so that we can take the reference of current. So as we are taking the current I, so the current is going V is equal to, what is the, if this is the current, and we know in the resistor the voltage drop, if the voltage drop is VR, VR is equal to, or here we wrote ER, ER is equal to IR. This is always, IR is equal to always, it is following the current. So I is equal to ER, and in the capacitance we know in the civil rule, I always leading, voltage is lagging. So voltage, if this is the current, the voltage across the capacitor will lag it by, the voltage will lag it by 90 degree. So it will be the EC, the voltage across the capacitor. Now what is the total voltage? Total voltage V, or total voltage E. The total voltage E, total is equal to ER plus EC. Now ER and EC we cannot add it simply, we will add it using the vector addition. So we will take the vector addition and we will get the ET. So what is the magnitude of ET? ET is equal to, and the angle is the theta with respect to the ER. Now what is ET? ET is equal to ER. What is ER? ER is equal to ET cos phi, and EC is equal to ET sin phi. Last class we have discussed about the value and how to calculate the value of theta. That theta is equal to, sorry, here we wrote theta. So theta is equal to tan inverse base. This is the base by this. So it is coming EC by ER. What is the angle? Angle is EC by ER. So this is the AC through the RC circuit. Now we are going to a problem. What is the numerical problem we are discussing here? An AC series RC circuit is made up of a resistor of 20 ohm and capacitor has a capacitive value of 30 ohm. Calculate the impedance and the phase angle theta. So what is the impedance? Impedance means we have to calculate the R, we have to XC, and we have to add this 2. So how to calculate this? So this is our resistance. What is the value of the resistance? It is given 20 ohm, and capacitance. So it is our R. And what is the value of the, what is the value of the capacitance is given? The capacitance value XC is given 30 ohm. And this is our supply. So what is the impedance? Impedance always we got from this diagram, you can get what is this line? This line equation should be ER square by plus EC square. What is this? This is the square root of ER square plus EC square. If I divide it by the current, because current is constant, we can get root of R square by X square. So we are using the same thing, root of R square plus root of X square. What is R square? R square is 400 and X square is equal to 900. So we are getting here. So we will get here. And how to get the value of theta? The value of theta is, again I am coming here, what is the EC by R? So if I divide it by I, we will get tan inverse XC by R. So what is the value we will get here? Tan inverse 3 by 2. So if we calculate it, we can get the value of the we will get the value of the phase angle of the circuit and the impedance. Next, we are moving to the AC through an RL circuit. So, just like the capacitance, pure RL is also not only pure inductive circuit is not available. The whatever is available is the R and L. L means inductor, means some coil. So here also you can see as we again go for the civil rule that voltage is leading and current is lagging. As this is a series circuit, we are taking the current. Here we are taking the current as the base. Now EL is also, what is EL? EL is the voltage across the inductor, and EL you can see is leading the current by 90 degree. It is not leading the voltage across the resistor. It is always leading the current. Remember this, voltage is always leading the current. So current is, because current is our base. So we can see this is the EL. EL is leading the current I by an angle 90 degree. So how to add this? We will use the parallelogram law. We have added, and here we will get the EL value. So what is ET? ET is equal to again root of ER square plus EL square. And what is ER? ET cos phi. What is EL? ET sin phi. What is tan inverse? Tan inverse is equal to EL by ET. If we write it in form of the inductance, means if we are dividing everything by current, as current is fixed here, we can divide everything by current. So Z is the impedance, is equal to R square plus XL square. We can write it R square. And what is the angle? Tan inverse EL by ET. So it is tan inverse XL by R. And what is XL? XL is nothing but the omega into L. Omega means 2 pi FL. Next, last question, we are discussing one numerical problem in a series circuit containing a pure resistance and pure inductance. So what is this? That one pure resistance and pure inductance both are connected with an AC circuit. The current value is given as IT is equal to 3140 plus 2 pi t, and voltage is 15 sin 340 plus 5 pi by 6. What is the impedance of the circuit? So what is the impedance? First, what is the phase difference? The phase angle of the current is 2 pi by 3. So it is 2 into 180 degree by 3 means 120 degree. And this is the 5 pi by 6 means it is 150 degree. So the final current, if we want to draw it, how to draw? That I is our base. This is our I, VR. VR means voltage across the resistance. This is our VL. This is our VL. So what is the value? This is our original V. Now, as what is the angle between original voltage and current? The current is 30 degree. So the current lags the voltage, and this is the inductive circuit. Current is lagging. You can see from the diagram also. Current is lagging by 30 degree. Now, what we have to know? What we have to do? We have to calculate the impedance. So we can see what is the impedance. If I divide everything by Z, everything by current, we will get the value of Z. So what is Z? Z is equal to V max by I max. What is Vm? Vm is equal to V max by I max. What is V max? V max is given as 15, I max is 5. So Z value we are getting as 3 ohm. We are getting the value is 3 ohm. Now if we are drawing one circuit, this is our R, this is our XL, and this is our Z. So what is the relation and this is theta angle. What is the relation between R and Z? The equation is, what is the relation? The relation is Z is equal to R, R is equal to Z cos theta. We are using the same thing here. The angle we got, it is 30 degree. So R is equal to 2.6 ohm. Again, XL by Z is equal to sin 30 degree. So we got the value of XL is equal to 1.5 ohm. Now we have, what is our question? Question is question number C. What is the inductance in Henry? So how to get the inductance? We know inductance omega L is equal to 1.5. Omega means 2 pi FL is equal to 1.5. What is the frequency is given? The frequency is not given. If frequency is not, okay, here it is given omega T. So omega value is equal to 314. It is given. So 314L is equal to 1.5. Why? Because current is equal to 5 sin omega T. So obviously if we compare 5 sin omega T, so what is omega? Omega is 314. So omega is 314 into L is equal to 1.5. So L is equal to 4.78 millihenry. So these are the textbooks I followed for today's class, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.